Hello everyone, thank you for the kind introduction, and I'm very excited to be here. And so today I'm going to talk about sequential decision making in recommendations. So as you all already know and are all probably very happy Netflix subscribers, Netflix provides a subscription service to allow its members to watch content online. So the goal of the Netflix homepage is to quickly allow members to find the content that they would love to watch as soon as possible. The risk is that if members do not find the content that they like, then they may lose interest and even cancel the subscription. So the challenge is that we are a global company. We have about 158 million subscribers spread across 200 countries. So even though we have global members, we need to cater to personalized taste. So as you would imagine, recommendation algorithms form a key component of the Netflix service. So we have recommendation algorithms for everything, from what shows to recommend to the members, how to organize the titles within the rows, what rows to show to the members, how to have the right names to show for the rows, how to organize the results when you search for a title, how to show the right image to the users when you see a title. And even when we reach out to you saying that you might be interested in a particular title, that content is also personalized. So it would not be wrong to say that everything at Netflix is actually a recommendation. So let's look at the user trajectory when they come to the Netflix website, when they come to the Netflix homepage. What are the sequence of activities that they come and do on the Netflix homepage? They can come, they can visit, they can click on a title that they like, they can play some title that they like. They can, let's say, if they play another title that they like, they can even thumb it up. They can add a title to my list so that they can view that later on, and so on. What we want to do as Netflix, what we want to do is try to optimize for the satisfaction of the users. So given this trajectory of the users, how can we optimize for the user satisfaction? The important question over here is how can recommendation algorithms take this into account while recommending titles to you? So there is a very good class of machine learning algorithms called sequential decision making that help us in this. So sequential decision making algorithms have been widely used and have been very successful in many domains. For example, in AI for games, in case of clinical trials, when to determine what medicine to give to a patient, in case of network routing, in case of online advertising, and also even in the case of hyperparameter optimization in machine learning. So in case of recommendations, what we want these algorithms to do is that we recommend some title to the members. They provide us some feedback, some observations, and some reward. We take that back into account and recommend it to the members. So the general setting of a sequential decision-making algorithm is like this. We have a learner which interacts with the environment. So the environment provides the context and presents it to the learner. The learner selects the action that the user would be interested in and presents it back to the environment. The environment then generates the reward and presents it to the learner. And this is how the learning continues. So why are these kind of algorithms challenging? They are challenging because we don't know. Because we don't know many things. For example, we may not have full knowledge of the current environment or the state we are in. We may not have full knowledge of the reward. For example, taking an action can result in certain amount of reward. We don't know what is the reward that we get from recommending a certain title to the users. We don't know the transition dynamics as well. We have no knowledge of how the environment changes and adapts to the user. So let's look at a very small subclass of sequential decision-making algorithms called multi-arm bandit algorithms first. The idea of multi-arm bandit algorithms is derived, it's a very well-known idea, and it has been studied in the literature for like the past many years. And it is somehow inspired from the idea of gambling in a casino. So imagine that there is a gambler who can operate on multiple slot machines at the same time. And the goal of the gambler is to maximize his earnings or maximize the reward that can be obtained from playing the various slot machines. So the question over here is, which slot machine should the gambler play in order to optimize the reward? Note that the reward distribution for the various slot machines is unknown. Because if it were known, then all the gambler has to do is pick up the slot machine with the highest expected reward and play that multiple number of times, and that's how it can maximize his highest expected reward. So how do we learn in such a scenario? So at the heart of these multi-arm bandit algorithms is the exploration versus exploitation trade-off. What does it mean? So it means that at a given point of time, let's go back to the recommendation problem. It means that should you recommend the most optimal title given the evidence you have, which is known as exploit, or should you try to recommend some lesser known title to gather more feedback on it, which is explore. So multi-arm bandit technologies have been studied in the literature for a lot of number of years, and you can find a whole bunch of literature around them. But broadly classifying them, they can be classified into these multiple categories. For example, there could be different strategies that can be used in exploration versus exploitation. There could be simple epsilon greedy approaches that could be used for exploration versus exploitation, Thompson sampling, upper confidence bound, or other approaches. There could be different assumptions that could be made on the environment. For example, is the environment stochastic and stationary? That means that is the reward generated from a distribution which is very specific to the action, or can the reward distribution or the other kind of algorithms are adversarial, in which you make no underlying assumption on the reward distribution for a particular action, and the reward distribution itself could change over time. There could be different objectives that you want to track. For example, do you want to track the cumulative regret, or do you want to find out the best known expert? Similarly, the set of actions could be different. The set of actions could be discrete. For example, in the case of title recommendations, we have the different titles could be the set of arms, or they could even be continuous. They could be finite, they could be infinite. And there are several other extensions that have been studied in the literature. Some of the very intriguing ones are contextual multi-arm bandits and the bandits with varying set of arms. So let's look at a very simple example of epsilon greedy approach for the multi-arm bandit. So what happens in the epsilon greedy approach is that you toss a coin, and then with the probability epsilon, you decide whether you should be exploring, or whether with the probability 1 minus epsilon, what you do is you exploit. Exploit, that is select the most optimal title. So going back, taking this problem back into the title recommendation, if we have a greedy exploit policy, it would look something like this. The member comes on the Netflix homepage. We have a candidate pool of titles that we can show to the member. We extract the features from these titles, and maybe, let's say, even get the features from the members. We have models which compute the probability of play for the title. And let's say we pick up a winner depending upon the highest probability of play. So this could be an example of a very simple greedy exploit policy. Note that even in a very simple greedy exploit policy, there are several challenges, and we need to take into account several things. For example, when we are trying to design the explore, we need to think about how much bandwidth should we allocate for exploration. The reason is, if we allocate too much bandwidth for exploration, we do not want to hurt the member experience. On the other hand, we also want to think about what titles would benefit the most from exploration. Whether new titles for which we don't have as much feedback would benefit more, or whether existing titles for which we already have information would benefit more. Similarly, for designing the exploit part of this epsilon greedy, we have to think about several things. For example, is a title available in the country? What is the frequency of the model update going to be like? Are we going to have an incremental training, batch training? How should we take that into account? Because the model needs to be updated. It's a continuous model which is continuously learning. How should we take that into account? And also note that the title popularities could be non-stationary. So how should we take that as well into account? An important point to remember is that the Netflix homepage is an expensive real estate, and there is a cost associated with promotion. So there are, like, if you think about it, there are so few opportunities to win the moment of truth with the members that we have to be very careful about what we recommend to the members. Let's take a very simple example. Let's take that this user, let's say, likes to watch this title Dark every day in the evening. So every day in the evening, let's say the probability of play for that user, for that title, is very high. Does that mean that every day in the evening we should recommend that title to the user? Probably not, because we want to be able to utilize that space a little bit better. So also note that we have lots of feedback loops that occur on the Netflix homepage. For example, when we are showing a title on the topmost portion of the Netflix homepage, maybe it is influencing you to play some title from other rows. And similarly, when you play a title from the other rows, maybe that play information is helping the algorithm on the top row, and so on. So there are a lot of feedback loops that are already going on the Netflix homepage. And so what we want to do is not design an exploit policy which is only recommending a title depending upon P of y given x, that is the probability of play. But we want to build an exploit policy which takes into account the causal effect of the recommendation. It's kind of incremental as well. It takes into account how the user will react to this recommendation. So how do we do that? There are several ways in which this can be done, like some of the bandit approaches can also be helped for this one. And of course, there is like a literature from other people on how we can make sure that the recommendations themselves are causal. So we try to bring some of that into the bandit space. So we talked about multi-arm bandit approaches. Let's talk about the other approaches for sequential, or the major approaches for sequential decision making in recommendations, and the new cool kid on the block, which is reinforcement learning. Note that when we started, we were talking about we want to try to maximize the long-term user satisfaction for the user. So what we care about as a service is not just to optimize on plays or clicks or play durations, but what we want to do ultimately is try to optimize for long-term user satisfaction. So how do we bring that into the algorithms itself? So note that this is a very, very open question, and this is a research direction that we, along with several others, are trying to get into, and it is not a solved problem. So before we jump into, let's look at some of the preliminaries, some of the things that are needed for a reinforcement learning algorithm. So the state is basically everything that we know about the user. The action is the recommendation or the title that we show to the user. The user preferences is represented by P. Then let's say there is a reward, and there is some initial starting point, and there is also some discount factor to how should we treat the future rewards. For example, when I present you a title right now, how am I going to look at the reward that happens 10 days from now? So obviously, you're not going to say that if a user has streamed a lot 10 days from now, maybe that is because of the title you have shown. So there is a discount factor that you need to take into account for that. So there are a couple of popularly used approaches. Not popularly, I would say, because like people are still trying to learn how to bring this problem of reinforcement learning into recommendations. But this approach is one which is a published paper, and is trying to bring in policy gradients into recommendation. So in policy gradients, what you are trying to do is directly optimize for the policy. What is the policy doing? The policy is just trying to obtain the cumulative reward in the future. And let's say that the policy is parameterized by some theta. And if you, it's a non-policy learning algorithm. So you directly try to optimize for the policy and try to present that action to the user. And again, people are still trying to figure out, like these deep Q learning approaches have been shown successful in other domains, for example, in playing games. So how can you bring those techniques into recommendation space? So it's definitely a difficult problem in the recommendation space as compared to AI for games, in which the problem is a little bit more well defined. For example, the state, etc., are more well defined in the case of AI for games rather than in the case of recommendation. So these deep Q learning approaches try to optimize for the Q value. The Q value tells what is the optimal value for a state action pair. And this is also an open problem, and there are several challenges on how should we make it work in practice. So not just this, there are like many more challenges that come along with the reinforcement learning approaches and our grand goal of trying to optimize for the user satisfaction. For example, the space itself could be high dimensional. So when we look at the Netflix homepage, we don't want to care about like one single title recommendation, but what we care about is how can we construct the page itself better for you. So that makes the combination of titles that can fit into a page a lot, and so how can we take that into account? Another challenge is from off-policy correction. How can we learn from data that we collect from an existing policy, and how can we apply that, and how can we offline learn that this policy that we want to implement and apply is going to be better than the other policy. So there are several challenges that come from the off-policy space. Reinforcement learning especially brings in the challenge of having a simulator. In case of multi-arm bandit approaches, you can still try to estimate how a policy is going to be offline versus the other with the help of replay kind of techniques. But in the case of reinforcement learning, you need some kind of a good simulator. And so how do we even construct a good simulator? So that's like another like line of research. Again, like how do we take into account the nature of changing rewards? Every action may change its ground truth. Titles become less popular, titles become more popular. How should we take that into account? Changing action space itself. Titles come into the service, titles leave the service. How should we take all that into account? So with that note, I would like to thank you all for listening to the talk and also to several challenges that come in this space.
Hi. I had a question about like the feedback loop that you were talking about on the main screen.
Yeah.
So what happens if a title is removed from Netflix? Like, for example, I heard recently Friends is no longer going to be on Netflix. So how will my recommendation change? Or like, will that be taken into account when the data points are removed?
Yeah, definitely. So yes, the action space itself is changing in this case. So let's say if we consider the action space to be a title, the action itself has been deleted. So like you have to think about algorithms which take, for example, multi-arm bandit algorithms, most of the literature focuses on fixed action space. But now when the action space itself has changed, how do you take into account that? So I think you have to modify your approaches a little bit to take that into account.
So what about like, because I watch Friends, there might be some other recommendations which might be linked to that. Will those also be removed or will they be kept?
So as you can imagine, so the action or the title itself has got several features, for example, genre, etc. as well, that go into like what you have liked. So you can use all that information still, probably. It depends on algorithm to algorithm. Some algorithms can take that into account, but ideally I would assume is that like you have, you represent your action. For example, in the case of linear bandits, which takes this into account, in the case of linear bandits, what you do is try to map your action into some other high dimensional space, and then you operate from there.
Okay. Thank you.
Yeah.
Thank you for sharing the technology used in Netflix for recommendation. And I have a question about the sequential decision-making approaches, especially by using reinforcement learning. So my question is, I guess there are a bunch of techniques that you evaluate and use in Netflix, compared with the traditional like machine learning and also deep learning technology used for recommendation. So how do you like evaluate the reinforcement learning? Do you have any like conclusion to see like the reinforcement learning based approach can be better in some cases than the other traditional recommendation approaches? And how do you validate that in production?
Yeah, I think that's a very good question, and it's a very open question as well. So not just at Netflix, I think people all around the world are trying to see like how we can bring this new cool kid on the block, which has been shown successful in other domains, into the recommendation space. So people are still trying to figure this out, and you would see like the paper that I talked about like was one by Google about like how can you bring like policy gradients or like techniques from reinforcement learning into recommendation. So I think it's still an open problem, like people have still not figured it out. But in the future, like you talked about deep learning, so in the future I would see that like these two approaches coming together, like you will see that techniques from deep reinforcement learning to be more popular. So you have to bring in definitely the advantages that deep learning brings into this problem of recommendation. So somehow you have to bring these two in together.
Thank you.
Yep.
Hi. I will talk like a father here, like a user first. You see, when I choose movies for my kids, the algorithm works just fine because it shows what I like to show to my kids. But when my kids take the phone and try to figure out by themselves, the algorithm breaks because perhaps it doesn't understand that is a totally different user. So, so I just broke your algorithm.
Yeah.
And that is the first one. And the second one, if you're considering segmenting your populations and trying to show, to recommend based on the segmentation, just to rebalance this exploitation and the other one.
Exploitation?
Yes, exploitation versus the
exploration.
Exploration, yes.
Yeah.
But not based on the person, but based on a segment the person is. Okay.
No,
so
no,
by some some demographics or.
Yeah. No. That's what we don't want to do, because we don't want to put some user in some exploration bucket wherein we always show random title. Obviously, people will not like it. That's not a right approach to look at the problem. So somehow we want to be sure that we are doing the coin toss in a correct manner, so that we are not bucketizing people or segmenting people into exploration versus exploitation.
But maybe country, a specific province or city or age group?
No. I don't think we look at those features at all in coming up with buckets. In fact, the coin toss, ideally what you would want to do, is regardless of whoever comes in, at a session level, maybe you want to do a coin toss and determine whether this session should be an explore or exploit, rather than bucketizing or segmenting.
Right, thank you.
Yep.
Hi Jaya, a quick couple of questions. Netflix has got hundreds of thousands of titles and millions of users. So building a recommendation model using any of the approaches that you talk takes a long time. So it's a kind of a engineering question. How often do you build a model and deploy that recommendations back to the user interface?
Yeah. So it depends. It depends on algorithm to algorithm. Some algorithms, for example, like multi-arm bandit algorithms by nature are meant to be online approaches. So you would want to have the updates much faster as compared to some other algorithms which can operate in a batch world. Let's say, some deep learning based or traditional matrix factorization based algorithms, which are batch based approaches, they can survive without having to publish the model very frequently. But yes, this completely depends on model to model.
Is there a benchmark that you have in Netflix? I'm just asking for the best practices to take home.
No, I think it very much depends on algorithm to algorithm, and we don't have any benchmarks as such. But depending upon the need, if we feel like we should have more frequent updates, we do it more frequently. If we feel that no, we can wait for whatever time, we wait. So it completely depends.
What's your thought on using inverse reinforcement learning rather than model-based reinforcement learning?
Yeah. So I think these are really good open questions right now. We haven't come to a conclusion to any of these things. Yeah. I think all those things look very cool and have been successfully applied in other domains. But when it comes to recommendation, there are many other challenges that come with it. So I think we are still trying to find out.
Do you know anything any approach that you guys used and try to do the inverse reinforcement learning, because anyone tried using it? Because I don't know anyone used it in the kind of recommendation. So
I have not personally come across anything, but yeah, if you have come across, feel free to send it across to me.
Yeah, thank you so much. Yeah.
Hi, this touches on a question that happened previously. So obviously Netflix's user base is wide and diverse. So have you ever done any analysis comparing a single global recommendation model versus several regional recommendation models, and how maybe the regional model will address some things better than the global one?
Yeah. So this is a good question that we have members from different countries, the training data comes from different countries. How can we organize, or what's a good approach, whether it should be a global model, whether it should be a local model, whether it should be a sub model, and so on. So there are different approaches. Even if you see the literature, you will come across there are different approaches. For example, even if we pick up deep learning, you will see that there are many ways to handle this problem. For example, some people use when you have small training data available from some places, people use techniques like fine tuning, etc. Train on a larger data set and fine tune on a smaller one. So there are I think many ways to look at this problem, and depending upon the algorithm as well, we also try to borrow techniques.
And how does Netflix view that problem?
I think it again it depends on algorithm to algorithm, and there are so many algorithms operating on the Netflix homepage that I would say that there is no one specific way or one specific hammer that we have found to solve this problem. Yeah.
It's a great presentation, and so many questions is a good sign, right? So again, very quickly, from a customer satisfaction perspective, you mentioned it's important to all of us.
Yeah.
So you guys don't send any surveys as far as I know. So how do you measure that? I believe engagement is a factor. I know clicks can tell you if the client is engaged or not.
Yeah.
But how about satisfaction?
Yeah. I think that is where we want to go in as well. It's a very open question, and there are some surrogates that you can use It's still, I would say, is a research question. How do you measure it? Like, how do you measure satisfaction? You could use like some surrogates, like as you would imagine, like whatever you can think of, like a user doing a thumbs up or whatever, some surrogates. But there is like still, I think, much left to understand. How should we actually measure it?
Fair enough. Thank you.
Yep.
Hi, thank you for the presentation. So a lot of your presentation was based on user action. You said if they take this action, we'll give them some reward. How do you guys incorporate if a user, let's say, doesn't take any action? So I browse for 10 minutes and I decide I don't want to watch anything.
Yeah.
How do you account for if the user didn't like anything or if they just didn't have time and they decided they can't watch it right now?
Yeah. That's a good question. So one way, and it also again, sorry, depends upon algorithm to algorithm. But one thing that you can say is that if the user is just coming into the service and is probably not liking anything and not playing anything, it probably means that we can take like the recommendation as a negative. That could be one way to think about it. So you can organize the training data in that manner. So that could be one possible way of dealing with it.
Thank you.